So just like we used um, R to help us to calculate values or probabilities on the standard normal Z distribution, we're going to do the same thing here. So we may have a value, or you could call this a critical value. Okay. Or we may have, we may be interested in a probability or a proportion. Or a p-value might be another way to sort of think about it. Okay, and so if you have the probability or the proportion and you want the value, that's when you're going to use this QT command. So I've kind of outlined those here. Okay, so if you have the probability in the one tail, right, and you know how many degrees of freedom there are, you can plug it into this QT formula where P is going to be the area, either to the right or the left. And degrees of freedom has to be given, and then you're going to tell it whether the area is the right or the left by using this argument lower tail is equal to true or false. And that's going to allow you to take that probability and work out the critical value, right? So, so going this direction, right? Maybe I should draw a little picture here, right? So you have your t distribution with so many degrees of freedom. This area here is known, right? And we're working out the actual value, okay? And you're gonna need that when you go through and construct confidence intervals, and we'll talk about that, okay? The other thing is you might be given sort of a value or a critical value that could be a test statistic too. Okay. So that's when you're gonna sort of go through and you're gonna say, okay, I have my test statistic. So this is the known value. And here, this area is what you're trying to figure out. Okay. And in that case, we're going to use the PT command. And so I've sort of outlined that here. Okay. So again, in general, you have to give it the value. So quite often this value will be your test statistic, and we'll do an example of that. The degrees of freedom will be known. That'll be given in the problem because they'll give you the sample size N. And again, just make sure you specify whether you want the area in the right or the area in the left-hand tail. Okay, and you can use the lower tail is equal to true or false to get at that argument. So for example, okay, suppose I want to figure out what the value is where the area to the right is 0.025 on the t distribution with 84 degrees of freedom. So just to draw a picture of the situation so we can sort of see, there's the t distribution with 84 degrees of freedom. Okay, we want to know the value, so I'll draw on a value. This is the value here where we want to know the area in the right-hand tail is 0.025. So in this case, we're going to have to use one of those commands, but in this case, we're going to want to use the QT command in R, right? Because that one is the one that's going to give us the value where we know the probability. So in this case, we know the area in the right-hand tail, so I'm going to plug that in for P. I need to give it the degrees of freedom, and that's given in the problem, that's 84. And because it's the right-hand tail, I'm going to use the argument lower dot tail is equal to false. So I'm going to plug that command into R. So here I am in R, and I'm going to plug in that command. So I'm going to type in the console QT 0.025, 84, and then lower dot tail is equal to false. And that will spit out a number, 1.98861. So I'm just going to write that here. It was hold on, I've lost the number, 1.98861. So that's this value here, okay? Okay, that's the value that falls on that distribution. And if I just wanted to sort of write that in the notation, right? we could say the critical value T, and then the area to the right was this 0.25. And then 84 degrees of freedom is equal to 1.98861. That we just to sort of write it in the notation. Okay. The other thing that you might want to do is you might want to figure out the area to the left of a particular value. So I'll just draw the T distribution with 84 degrees of freedom. And then I'm going to plot on my value minus 1.57, which is going to fall to the left of the mean. And I want to work out the area to the left. So I want to work out this area here. That's sort of the unknown. Okay. So in this case, because I know the value and I want the area, I'm going to use the PT command. P because I'm looking for a probability, and T because I'm wanting it on the T distribution. Okay. Then I have to feed in the value, so that's minus 1.57. Okay. And I'm going to give it the degrees of freedom, 84. And then in this case, I'm going to do lower dot tail is equal to true. Okay. And by doing that, it's going to tell me the area to the left. So I'm just going to move on over to R. And I'm going to type in my command PT, and then I'm going to tell it the value, which was minus 1.57. And then the degrees of freedom was 84. And then I'm going to tell it lower dot tail is equal to true because I want the area in the left-hand tail. And that's spitting out 0.06. That's the area to the left. So I'm just going to write that in here on that area is 0.0600872. I usually round these to about 3 decimal places. I'm not picky in this class. Whatever you think makes the most sense, but usually I think 3 decimal places is pretty good. So again, that gives us this area. So this area is known, that shaded area, that's how big it is, about 6%. And again, if I wanted to write this in the notation, you'd say T of 0.06, let's just round to there. And then my degrees of freedom is 84, is equal to minus 1.57. So that's kind of how that works. So hopefully that helps you to answer some of the questions on the quiz and feel more confident with this as we move forward in using the T distribution for confidence intervals and for hypothesis testing.